Okay, so we apologize for issues. We'll try to speak from this microphone until the first block. To maybe we can put this closer for the proper sound. Yeah, it's working. Okay, we'll switch the camera for the presenter view, and in the meantime, let me open my slides. So the next presentation will be given by Professor Kamal Jain from India. Are you here, Professor? Who wishes to do the presenter role? So
Good evening, sir.
Okay, yeah, we can give you the presenter role.
Sir, my name is Akshay Pandey. I am giving the presentation on behalf of Dr. Kamal Jain. I have done this research, that's why.
You can share your screen now.
Thank you, sir.
Perfect. Thank you.
Good evening to everyone. My name is Akshay Pandey. I have done this recent publication in Computer Electronics and Agriculture under the supervision of Dr. Kamal Jain. Good evening from India. This is our recent article published in Computer and Electronics and Agriculture, an intelligent system for crop identification and classification from UAV images using CDCNN. So I think all we know about the unmanned aerial vehicle, or also referred as drone. UAV is an aircraft without onboard pilot, so the name is unmanned aerial vehicle and controlled by the onboard computers. In 21st century, UAV technology reached a point of sophistication. According to the survey of US government, 75 countries have adopted drones for different applications like packaging, delivery, monitoring, survey, sports, armed attack, etc. Drone technology has also left a long-lasting impact on the agriculture industry, like crop monitoring, pesticide spraying, crop stress identification, crop classification, and many more. With the help of crop identification, governments and agriculture managers required information on the spatial distribution and the area of cultivated crop for planning purposes. Seeing the increasing population of the world, it can be estimated that by 2050, the population of crops will have to be doubled. So, precise farming is the single option for sustainable development in agriculture. It means crop classification, crop identification is required. A single tool for identifying multiple crops will reduce the human effort. Further, agriculture lands are stretched at all over the India and world, and it is not possible to find an expert for successfully operating different crop identifying tools. So, if an automatic crop identification tool can be developed, then any non-technical person without any non-technical knowledge also can identify a specific crop without having deep knowledge. To serve the above aim, this work process automatic algorithm for identifying multiple crops using a single deep learning based tool. If we are using UAV for data collection, the benefits are drones are used as large scale farming due to its remote control operation from distance. They are easy to use with basic training. It provides good return of investment without any crop damages. We can use RGB multispectral sensor, thermal sensor, hyperspectral sensor or camera. Due to more than 3 bands, multispectral, thermal, hyperspectral contain a lot of redundant data. And it may happen that due to the large amount of redundant data, the classification result become misleading. So in this regard, RGB images are better than other. So we use in this research RGB images. From the literature survey, some author done classification to segregate crop covering land from non-crop land. Mainly, machine learning based bi-level classification is done. However, implementation of machine learning requires huge feature extraction from different complex mathematical operations. This is quite tedious job. Deep learning, especially CNN, is better than, but the possibility of using CNN for multiple crops identification it still is unexplored. These are the different CNN learning mechanisms, plain CNN or forward propagation learning. In plain CNN, multiple convolution operation performed. First convolution operation output is served as a next convolution input operation. Residual learning, it is also similar to plain CNN, but after 3 or 4 convolution operation, first input data is also added with the convolution operation for the next input. Just because of this convolution operation or this feature loss is very high in plain and residual learning. In dense learning, it is resolved, which is proposed by us in our research, using both input and output of the previous layer as input to the next convolution layer. This is the overall RGB image, crop image capturing by using UAV. In our study, we use Phantom 4 Pro V2 UAV for data collection with 20 megapixel digital camera. These are the flight planning steps, side overlap, front overlap, and the photo collected. So these are the samples like rice, sugarcane, wheat, beans, and grass, which is collected by the UAV. These are the complete steps for overall processing. The first step is candidate crop region extraction. Crop and non-crop regions are segmented for creating proper data set. Size of the captured images by UAV is 5472 multiply 3648. The candidate crop region extraction and image resize done by Python. And the second stage is the input of the CNN to the candidate region. CNN mainly has 4 operations: convolution, max pooling, flattening, and last one is output. In convolution layer, filters are used to extract feature from the input image. The filter will overlap to the input feature map and perform convolution operation. As an output of these convolution operation, new convolved feature map generated. The max pooling operation will reduce the size of the convolved feature map. In max pooling, small elements are selected and minimum and maximum values within this small region is selected as the output. Therefore, the output result of feature map will half of the input convolved feature map. Max pooling is used to reduce the computation time as we are eliminating less important elements from a region and only selecting the dominant or significant one for further processing. Ultimately, flattening is done. This flattening is done, and the single vector, column vector or field are of them artificial for use for artificial neural network. ANN will assign the weights and find out the best probability for the classification for each images. This is the proposed CNN, CD-CNN architecture. Here, R1, R0, RL minus 1 are the feature map concatenation of layer 0, 1 and L minus 1. FL is the composite function. This is dense block architecture used for the crop identification. It is noted that both input and output will be used for the next layer input feature map. The dense block contains a function which perform batch normalization, convolution, as we already discussed, the convolution operation. Now each convolution layer has an activation function to eliminate any redundant outputs. Generally, ReLU and SeLU activation function are used where ReLU makes the negative values to 0 and SeLU modifies the negative values. But none of them changes the higher value above the 255. In this work, we used a new activation function named SL-ReLU is used by merging soft sign, ReLU and logarithmic function to find out the best result. With this new activation function, the overall dense learning process is designed for crop identification from UAV images. Here, the architecture, here two dense blocks are used and in between them of one conversion block is used. The previous layer of inputs and output are merged as input to the next layer. Here we can see that after the operation of dense block 1, max pooling is performed here in the conversion block to reduce the size of the feature map, and that will speed up the feature maps processing, training processes. After the dense block 2, the output is passed through SL-ReLU here. Again, they eliminate the unwanted values and then finally classified with the help of flattening and softmax function. The purpose of the softmax function is to allot probability of each class corresponding for each image. An image will be classified as a particular class if the assigned probability is highest for that class. In this 5 class of crops, we use 2000 total images are used here. Right? From 2000, we use 1400 for training purposes and remaining 600 for testing purposes. Evaluating the efficacy of the proposed model, these are the parameters which are calculated and confusion matrix is generated. So this is the confusion matrix for different methods. Confusion matrix for random forest, for shift SVM, for LXNet, VGG16, VGG19, ResNet, DCNN, dense CNN, CDCNN. So here we can see that this diagonal row shows the best classification accuracy. So here we input 600 images and 376 is classified correctly, and remaining are misclassification. So this is the confusion matrix. This is the performance evaluation, classification accuracy of testing samples from different machine learning, standard machine learning algorithm, standard CNN algorithm, and our proposed dense CNN. So here we can see the highest accuracy in bold. So we can also compare with the other proposed CNN or machine learning algorithm. Our CDCNN showing the best result. The upper figure shows the training process of different CNN architecture. It is seen that training process is stable with rolling iteration. However, training process of LXNet, VGGNet, and VGG16 fluctuation in the training accuracy is more. Other CNN expect CDCNN. This shows good training process of CDCNN. Here we can see that this is the CDCNN process. Further investigation is done. Choose the accurate number of the dense block in CDCNN. So in first, if we are using the dense CNN, means only one dense block is used. The accuracy is 94.80 and the time is 57.4. If we are using the CDCNN, two dense blocks, the accuracy will increase 94 to 96.20. And also the time is also increased. But if we are applying another dense block, means CDCNN 2, then the accuracy will increase only 0.60 and the training time is 20% more than. So our CNN architecture, CDCNN, best showing the best result. This is all the activation function comparison. So CDCNN work with ReLU, CDCNN also accuracy with CeLU, and CDCNN with our new activation function SL-ReLU, soft sign logarithmic ReLU. So here we can also see that the accuracy is 96.20, and these are all the parameters. And this is the graph which is showing the training process, training accuracy in per unit. So in view with the aim of crop identification and classification processes, in this article, initially high resolution UAV images are collected for different croplands. A new CNN architecture named conjugated dense neural network is proposed with a new activation function named SL-ReLU present in the convolution layer. The training time is significantly lesser and accuracy is high from standard CNN. So now we are able to identify multiple crop using single tool, which help policymaker, manager, and also farmers. Thank you.
Thank you very much. If you have any questions, please type in the chat. Thank you. Okay, so now moving back to the stage for the in-person attendance. So, Nicholas, I think you are the next president.